Welcome everybody to 60 Minutes in Space. My name is Jose Zuniga. I am one of the science educators here at the Denver Museum of Nature and Science, and it is my distinct pleasure to bring this wonderful program to you this evening. I just want to make a quick note. If you do need closed captioning, at the bottom of your Zoom screen down in the menu, you should see something that says live transcript. Go ahead and click that little arrow next to the CC and click show subtitles. We should be able to have those for you. I am joined by two very, very knowledgeable people. Every time I hear them speak, I learn something new. We are joined today by Dr. Chun and Naomi Pequette, two of our experts here at the Denver Museum of Nature and Science. They've got some really awesome stuff to share with you today. As they are speaking, you might have some questions that come into your mind, and we'd love to hear those questions from you. You can post those in the chat. If you do have a question and it doesn't seem like we're getting to it right away, just be patient. We will get to the Q&A in the last 15 minutes of our 60 Minutes in Space. And if you feel like we're not answering your question, please type your question just once. I know you can be very eager to get a particular question answered. But since there are a lot of us here today and I'm the one monitoring the chat and I am not very good at reading it very quickly, please be gentle on me and post those questions just once. With all of that out of the way, without further ado, I'd like to spotlight Dr. Chun here to begin 60 Minutes in Space.
All right, thank you very much, Jose. And I need to actually get my PowerPoint in order, but I will now go ahead and share my screen. And so, yeah, welcome everyone. And so normally I cover topics outside of our solar system, and my first story will be on an observation of a jet from a supermassive black hole in a galaxy very far away. But my second story will actually be a little bit closer to Earth, and it will kind of nicely segue with Naomi, who will be covering topics very close to home. But this is a paper that just came out, and it's about using the Event Horizon Telescope to observe a jet coming out of the supermassive black hole in the Centaurus A galaxy. And the Event Horizon Telescope, you might remember from a few years back, they came out with the very first image of a black hole. And what they did was involve numerous radio telescopes across the globe, and they collectively observed the black hole around M87. And this was an image that was published and hit the front pages of newspapers all around the world for people who still got paper copies of their newspapers. And the new research involves looking at a different galaxy, so not M87, but the Centaurus A galaxy. It's the brightest radio source in the constellation of Centaurus. And if you observe or peer at the center of this galaxy with a set of radio dishes like the Naomi very long baseline interferometer, which involves multiple radio telescopes across the southern hemisphere in South America, Africa, and Australia, you actually see a jet emanating, actually two jets, one on either side of the supermassive black hole. But the new paper kind of zooms in, and so those dashed lines show you the region that it's looking at, and it really shows you that you have this kind of funny looking structure as you go in towards the black hole. It almost looks like there are multiple jets coming out. And so what I want to do is just talk about what we're about to, learn more about what we know about supermassive black holes, and see how that can guide us to our understanding of what this paper is showing us. So many of you are probably familiar with, or at least have heard of, less massive black holes. Black holes we often think of as the end stages of supermassive stars, and the most massive stars, after they blow up in a supernova, if the remaining core, as it collapses inwards, is past a certain threshold, it will keep on collapsing, and you have an object where not even light can escape. once it falls past the event horizon. And so we know about black holes because in the past, well, in the past, but even now, we can observe X-rays and other radiation coming from them. And oftentimes black holes are found in binary systems where you have a black hole and another star in orbit around each other, and gas is being drawn from the other star. It piles up in the accretion disk, and as that gas spirals in, it jams up, it gets heated to millions of degrees, and it emits copious amounts of X-rays. And because the amount of gas falling into the black hole is rather, can be sporadic, that X-ray emission is also somewhat random and sporadic. And the other thing that we've also known about black holes is that they can also emit jets of matter. And this can seem very counterintuitive because you have material falling in as well as material falling out. And so that is sort of what we're seeing here is that in addition to the material going down into the black hole, there's also material that's getting ejected out. And so here again, we're looking at the Event Horizon Telescope, but what we're going to do now is we're going to zoom out. And so on the lower right, you can see a little arrow that shows you the size of or the scale of the picture. So the scale that we're looking at is on the order of light days, meaning it would take multiple days for a beam of light to traverse this image from the left to the right. But as we zoom out, so we zoom out to that little box is what we saw just before. This is the Naomi VLBI image of that same jet. And then we will zoom out again. So making that box even smaller. This is both an optical and an X-ray view of the Centaurus A galaxy. And you can see that the galaxy has kind of like a torus of gas and dust surrounding it, the center. And then you also see evidence of those two jets. Now, at much larger scales, you're actually seeing the jets plowing into the intergalactic medium, and it's causing very bright X-ray emission. And so we're both seeing visible light imagery from a ground-based telescope, as well as X-ray imagery, the very faint blue that surrounds the jets, kind of further away from the galaxy. That's from the Chandra Space Telescope. And then we're going to zoom out even further, and you can see just how immense the impacts of these jets can be. So they're basically churning the intergalactic medium around this galaxy. And this visual shows you the full moon to scale. And so these radial lobes are on the order of about 9 degrees by about 4 degrees on the sky. So they're absolutely enormous. And so if your eyes were sensitive to the radio part of the spectrum, and if they were, perhaps the size of radio telescopes, you would actually see this enormous structure in the sky. So how do jets get launched from black holes? Well, this was a problem that people have been thinking about for close to 50 years. And a solution was first proposed. And this is a solution that is still relative, actually somewhat agreed upon. So there's actually a lot of evidence that this holds. But this was from a paper by Roger Blanford and Roman Znajek. Both of them were from Cambridge in the UK. And in 1977, they came up with this idea that you can think of, or you can imagine magnetic fields being embedded in the gas that falls onto that accretion disk. And as that gas spirals in closer and closer towards the black hole, it gets compacted and compressed, and the magnetic field gets compressed as well. And as that gas gets drawn in, that magnetic field gets also embedded into that black hole, or at least those magnetic field lines get anchored into the event horizon of the black hole. And then what happens is that for black holes that spin, and we think that most black holes probably do have some rotation, those field lines get spun around and they get twisted, and so into these into sort of a jet shape. and or into a sort of a long linear shape that gets extended along the north and south poles emanating from the black hole. And so it's these field lines that help propel the hot plasma out of the accretion disk and out back into space along the polar directions of the black hole. And since then, since these ideas were first put into paper, a lot of people, a lot of astronomers, physicists have worked on figuring out the details of how this would work. Part of the problem is that telescopes are not, up until very recently, we couldn't resolve or see detail down to this level. And so astronomers were, for the most part, sort of working in the dark, meaning they're figuring out the theoretical details of the physics involved in launching these jets, but you don't actually, can't really compare the theoretical results to observations until you get much, much further away. So it's only really recently that our observations have gotten to be good enough for us to start comparing the theoretical results and the computer simulations with actual observations. And so there have been a couple of different ideas about exactly, or at least two very broad ideas about the nature of the magnetic fields and the accretion disks, those disks of gas and plasma that's orbiting around the black hole. And back in the 1980s, one of the general dominant ideas was that the magnetic fields were actually relatively weak. And so what happened was that this plasma swirling around in the accretion disk was very turbulent. And so the magnetic fields were also turbulent and kind of randomly oriented. And the turbulence caused the plasma to lose energy. And then the plasma sort of fell inwards towards the black hole. And as the magnetic fields got jammed up right on the black hole's event horizon, that's when the black hole effectively spun those magnetic field lines up and launched the jet. And so here you can see this picture of kind of a jumbled looking accretion disk to the right of the black hole. In the 1990s, theorists started playing around with computer simulations and other simulations where they just increased the magnetic field strength just for the heck of it, really, it seemed like. And then what they found was they found a slightly different scenario where the magnetic fields actually dominated the physics of the accretion disk. And so what happened was sort of more similar to what you saw in that figure from the Blanford and Zanayak paper, where the very strong, sort of coherent fields controls the accretion disk and the infall of the disk. And actually, these very strong fields almost act like a force field. So it actually withholds a lot of the gas from falling in. And only a small fraction of the gas actually lands in the black hole, and a lot of it gets funneled out in the wind or in those jets. And so a couple months ago, there was another announcement from the Event Horizon Telescope, and they showed the M87 black hole shadow, but they announced these what they call the polarization results. And we don't have time to go to discuss exactly what polarization means, but it does relate very closely to the magnetic fields in the black hole, or at least surrounding the black hole in the accretion disk. And so you see these sort of curved, spirally lines around this image of the M87 black hole, and those lines represent the polarization of the magnetic fields. And the polarization results show a very ordered magnetic field. And so this seems to suggest that what we're seeing is more of that ordered magnetic fields idea in that top image, rather than the turbulent, kind of chaotic, confused magnetic fields in the bottom picture. And so a lot of people think that this really supports that ordered magnetic field idea. And even before this image came out earlier this year, just a couple months ago, the theorists have been creating lots of simulations of what exactly happens at very small scales. And so this animation shows you on the right the density of the gas that's going in. And you can see gas going in as well as gas being ejected. And on the left, you're showing the strength of the magnetic field as well as the strength of the radiation and power of the radiation that's being emitted. And then other people have also created simulations at slightly larger scales, where they include the accretion disk and then also the effects of the jets as you see them getting launched out, and they're impacting the interstellar medium of the galaxy as well as the intergalactic medium that surrounds the galaxy, the gas in both those media. And then there are other theorists who are creating these animations of showing the gas density and the magnetic field strengths, but they're also showing what a telescope like the Event Horizon Telescope would see if they were to look, if the telescope was to look almost directly down the black hole. That's the image on the very far left, lower left, and then the middle one, bottom, is about a 60-degree angle from straight down, and then the bottom right one is looking at the black hole from the side. And so if we come back to the Centaurus A jet, what we're effectively seeing is a single jet, even though you can see 4 strands of it. And the reason why you see that is because the gas that's emitting light that is being observed by the radio telescopes is densest along the outside of the jet. So you can think of the jet as being almost like there's a shell around a spine. And so that shell has most of the emitting gas, or at least the gas that's emitting the light. And so that, because you're seeing more of that, that shows up as these multiple sort of spurs. And we see that not only for Centaurus A, but for even the M87 black hole as well, the one where the Event Horizon Telescope first gave us of a close-up look of a black hole. And we also see that in other active galaxies where we have evidence of a supermassive black hole and an active jet. And so here are 2 other galaxies, and these are earlier papers, and the data were taken from telescopes that didn't have quite the same resolving power. But again, you can see hints of what the astronomers call limb brightening, where the edges or the limb of the objects are much brighter. So these results are very exciting because it shows that astronomers, radio astronomers, are continuing to probe using the Event Horizon Telescope to probe the very core of these black holes, and looking at the interface, or at least for Centaurus A. Actually, Centaurus A is far away enough, and the black hole itself is small enough that we're really not seeing the region where the jet is being launched, but we're definitely probing down into the details of the jet. And as our technology and our telescopes improve, you can be sure that in coming years, we'll be able to get even better observations and really nail down how these jets get launched. All right, so that's my extragalactic topic for tonight. And as I mentioned earlier, I'm going to a topic much closer to home, and that involves satellites around the Earth. And many of you are probably familiar with the Starling satellites. These were launched by SpaceX, the company headed by Elon Musk. And you might have seen videos on YouTube or elsewhere online where they're showing the launch. And the idea behind Starlink is to basically provide broadband internet service by using satellites. And they put these satellites in low Earth orbit, so about 300, 350 miles above the surface of the Earth. And each launch actually puts into orbit about 60 satellites. So what you're seeing going away from the rocket is about 60 satellites that will again then get deployed. And in just the last 2 years, so SpaceX started doing this in May of 2019, they have had on the order of about 30 launches. And there are more that will be planned this coming year and next year, although I don't think they've announced any dates yet. But currently, yeah, at least according to Wikipedia, there are about 1,700 satellites that they have put up. And you can find online videos that people have posted where they have observed these trains or these swarms of these Starling satellites. And some of you might have seen these yourself, since I'm sure many of you are amateur astronomers. And there's also services online. This is Heavens Above. This is a website where you can go to, and you can actually look at specific launches of Starlink. So this one is from the very first one, May 2019. So there wasn't very many, but then I went ahead and looked at one of the more recent ones, May 26th launch from this year. And you can see that train. And then here's another one from earlier in May, a different train after the satellites have spread out. And now you can also see all of them all at once. And you can see what 1,700 satellites can look like. And some of them are also polar trains, meaning they go over the poles, whereas the existing, the vast majority of them are, I think, between about 53 degrees north and south. And so the really interesting problem comes with the fact that you are launching so many satellites into low Earth orbit. And in the last 60 plus years that we've been putting satellites up into space and launching people into space, we've also had the problem of space debris, not only in low Earth orbit, but also higher up. And what we currently, the US Space Command, run out of NORAD in Colorado Springs, they're tracking on the order of about in excess of 19,000 objects larger than 10 centimeters, which is about the size of a softball. And space we often think of as being very big, but the more objects you put up into the relatively compact area of low Earth orbit, that also increases the chance of a collision. And so this is a plot showing the amount of space debris over time. And so it starts off in the late 60s, and you can see that the different colored lines represent different objects. So the blue line are the actual satellites that may or may not be in operation. But the pink line is fragmentation debris from satellites that have broken apart or have exploded. And you can see that in 2007, there's actually a big jump in the total fragmentation debris and the total number of objects. And that's because the Chinese government did an experimental test of what we can think of as a kinetic kill satellite, meaning they actually intentionally destroyed one of their satellites as a test of an anti-satellite weapon. And so that caused a major increase in the number of debris objects. And then also the next year, or a couple of years later, there was a collision between an Iridium satellite, which is used for satellite phone service, and a defunct Russian satellite. So a satellite that was no longer under control, and the two of them collided and also created a cloud of debris. And so increased debris and an increased danger to other satellites and to humans in space on board space stations, that's definitely of a concern. But another concern of these satellite swarms is their visibility. And so, normally if you are on the night side of the Earth, once the sun has set, you won't see any sunlight or effects of from the sun out in the night sky. But because satellites can be in orbit in sunlight for much longer than when you're in darkness. That means they can actually remain visible. And so until a satellite actually passes into the Earth's shadow, the sunlight can actually glint off of them and be visible, just like what we saw in that video from somebody's backyard. But this is definitely of a concern to astronomers because these satellites can actually show up in astronomical images. And so this was an image taken by an astronomer at a telescope. And that very bright streak is one of these satellites. And it's so bright, it's definitely brighter than the surrounding stars that she was trying to image. But what also happens is that not only there's pixels of that detector totally saturated, but it can actually also affect via the electronics of neighboring pixels, and the residual effects from that image can actually last for multiple minutes. And so that detector can effectively be kind of out of commission, at least for those affected pixels, for multiple minutes afterwards. But that's not just the only image. Astronomers have also posted images like this, where they're observing and they see multiple satellite trails. The left image shows a telescope used for monitoring meteorites. And so all the shorter straight lines that are all random are meteorites. And then the ones that are long and straight, those are the satellite trails. The one to the right is the big telescope in Chile that is used to image a large fraction of the sky. And those images can often be disrupted by satellite trains. Even the Hubble Space Telescope isn't immune to this, because Hubble can orbit lower than many of these satellites, or does orbit lower. And so Hubble has been affected. And then astronomers are also really worried about future telescopes. So the Vera Rubin Observatory, currently under construction, it won't be in operation. It will have first light next year, but its operation is normal operation is expected in 2023. But it's planning to basically stare and map the entire sky for every single night, meaning it'll map the entire sky over multiple nights, but it does this with a very large detector, and its intent is to look for changes in the sky. And that can be, again, very difficult to do if you have Earth objects that are flying past. And then satellite visibility, some of the takeaways is that at least the earlier generation of the Starlink satellites were brighter than about 99% of all previous satellites. And what that means is that previously there were less than about 200 satellites that were visible to the naked eye. And now we have effectively about 2,000. And those numbers will, we expect to increase, because not only Starlink, but there are other companies involved that are interested in putting up these satellite swarms. And so we could have as much as 100,000 satellites or more in the future. But because once astronomers and others became aware of this issue 2 years ago, there was a conference that occurred last year, last June and July, involving mostly astronomers, but also others other stakeholders who have an interest in this. And they do have some recommendations. So one idea is to deploy the satellites at keep them below 600 kilometers. And that keeps them to a level where they wouldn't be visible. I mean, they would be visible perhaps right after sunset and right before dawn, but you would at least keep them keep much of the night, at least keep them in darkness for much of the night. But because astronomical telescopes are so sensitive, there was also still a recommendation that they should darken satellites so that they would be below 7th magnitude. And then it would also be nice to have accurate orbital information available so that if a satellite train was to pass overhead, you could at least maybe turn off the detector, or if you knew when they were coming. And here is a plot showing what can happen if you have a bunch of satellites that are at 500 kilometers. You can see that they're visible a couple hours after sunset and a couple hours before, and then they disappear for most of the night. But if you put them up at 1,000 kilometers, they're visible throughout the night. And SpaceX has been listening to astronomers. There were representatives to that SatCon meeting last year, and because of this work, they were talking to the astronomers. They did try to darken their satellites, and they also added a visor over the antenna, which is the brightest part of the satellite, and they also added additional maneuvers to help minimize the amount of light that would get reflected to the surface of the Earth. And so far, it has helped. And so the satellites, this chart shows the 4 blue dots are the brightnesses of the satellites from an earlier generation. The black dot towards the bottom is one of these dark sats. And so it has a magnitude of about 6. So it's still unfortunately visible, and it's not quite the recommended 7 magnitude, but it is still 3 times less bright. Now, there are a number of, as I said, a bunch of other companies out there that have announced that they are interested in putting up communication satellites, these satellite swarms. And they're not just in the US, they're in the UK. Amazon is one of the companies, but they're in the UK, they're in China, and India, and elsewhere. So this is not just a US problem, but it's an international problem. And there was also another meeting that happened just a couple weeks ago, and there were some other recommendations, and basically the meeting was to help determine what strategies to have to accurately observe these swarms, and what tools are needed by astronomers to help mitigate the problems, and then also to talk about how to communicate to other stakeholders, and that includes amateur astronomers, people who care about dark skies, indigenous tribes, and to help start thinking about what sorts of policies, international and national, to pursue. And I also attended this meeting, or at least part of it. And so, and that's sort of the reason why I wanted to talk about this, because that's, part of, I think our job is to help communicate this issue to the public. But as far as my closing thoughts on this, the question then basically becomes, what is the future of night skies? And for all of us to think about, what value do we put into the night sky, especially a pristine night sky, and how do we weigh this against other needs? Obviously, broadband internet is really important, especially for people in rural areas who are really disconnected from, and it's very difficult and expensive for them to have internet service. So how do we balance that with other needs? So it's an open question, and it's definitely something that we will probably return to again in the future. So with that, I'm going to turn it over to Naomi.
All right, thank you, Chun. And mine is a pretty close dovetail off of that, because one of the things I wanted to look at this month is the impact of private spaceflight. Obviously, two of the biggest stories this month are around this idea of privatizing spaceflight in the next space race. And that is with Virgin Galactic and Blue Origins and their launches this month. So let's go ahead and take a look at what happened this month. So Virgin Galactic, excuse me, there we go. So Virgin Galactic was the first to launch. This is a company founded by Sir Richard Branson, who is a British billionaire. And their July 11th flight was called Unity 22. This was the 22nd test flight of the VSS Unity. So this is their space plane. And the milestone for them was this was their first fully crewed flight. Up until this point, they'd done 4 other crewed flights, but they had just been pilots. And we talked about one of those at 60 Minutes in Space in May of this year. So you can see there's a picture of the crew inside of the space plane. So this is a little bit of a different system than what we typically think of when we think of rocket launches into space. We think of, the Soyuz capsule, which has been taking astronauts to the International Space Station, even the SpaceX Crew Dragon capsule. So we think of a rocket going into space, and this is a technology called a space plane. And so what they do is they actually attach a space plane onto the bottom of what they call the mothership. And they launched from Spaceport, New Mexico. So it's making it another state that has reached outer space. And they carry the space plane up to about 50,000 feet. So the argument for this is that this is a much more pleasant experience for ultimately the customers that will be on site inside the ship. Then that space plane drops. It has a rocket hybrid engine that pushes it up into space. And for SpaceX, they are using what NASA and the US Air Force define as the boundary to space, which is about 50 miles, 55 miles is how high they got. For reference, Alan Shepard, the first American into space, got up to about 50 miles in his suborbital flight. This is a little different from what Blue Origin did in their definition of space. So we'll come back to that. So let's go ahead and watch a part of this launch. This was an hour-long event, multi-hour long event that was on television. The flight itself lasted about an hour from taking off to the spaceport to landing again, but we're just going to watch the clip where that space plane is dropping. So let's go ahead and take a look.
We're arming the launch pylon now. We are armed for release. 20 seconds. Ten seconds. 5, 3, 2, 1. Release, release, release. Clean release. Ignition. Good rocket motor burn. There's Mach 1 trimming now. Trim complete. Unity is pointed directly up and heading to space. Things are looking great. We are 25 seconds into the burn now, approaching Mach 2. 30 seconds, Mach 2. Everything's looking really good and stable. 40 seconds. 45 seconds. 50 seconds, approaching Mach 3. There's Mach 3. And 60 seconds, and that is a full duration burn, folks. We are headed to space. And the passengers in the back have been cleared to unstrap. Our predicted apogee is 279,000 feet and climbing. The pilots are now unlocking the feather, and as soon as they do that, it's going to initiate a backflip for Spaceship Unity. This is normal. We want those windows pointed down towards the Earth to maximize that incredible view. So feather is coming up now, and the pilots are also enabling the RCS, or Reaction Control System, which is what they'll use to control the attitude of the vehicle while we're outside the atmosphere. All right, feather is all the way up. We are at about 250,000 feet now and climbing. As soon as we cross the boundary to space, we'll hear a word from our founder, Sir Richard Branson. Welcome to Space, Unity 22.
Now, they did have some technical difficulties getting the live feed down after this point, but it was a very successful flight. Again, it lasted just under an hour, and the crew on board was able to experience a few minutes of weightlessness. It was about 4 minutes, a little longer than the Blue Origin's flight. You saw those beautiful windows all around, and those were for the crew to be able to look down on Spaceship Earth, if you will. So obviously the big news was that the company's founder, Sir Richard Branson, was on this flight, but they also brought along a crew of 4 pilots. There's actually 2 pilots to fly the mothership, and 2 pilots, which you see in this photo here, along with the rest of the crew that were flying the space plane Unity. And then the rest of the crew were all Virgin Galactic employees, and they were all up there to test specific things. So Sir Richard Branson was testing the customer experience. Sounds like a pretty cushy job. And you also have the chief astronaut instructor, because all of these future commercial customers will receive a little bit of training to make sure they're prepared for this experience. They had their lead operations engineer who was evaluating all the equipment in the cabin and the procedures during that boost where we saw that spaceplane drop and was boosted out into space, and that weightlessness. And then they did bring their vice president of government affairs and research, and she actually took an experiment from NASA and the University of Florida and ran an experiment to see what a scientist's experience would be like on this particular flight. So all Virgin Galactic employees, this is one of probably the most iconic photos that is going to come out. I'm looking back down onto Earth. Everything went well. And this has been a long time in the making for this company. You know, Sir Richard Branson won the X Prize with Virgin Galactic in Spaceship One. This is Spaceship Two, way back in 2004. And they've faced a lot of setbacks, but they did finally make it. And they're already looking to the future of their next flight. Now their former CEO will be on that one. And then they have lots of customers lined up. So Blue Origin followed. They actually announced their launch date first. We talked about that in 60 Minutes in Space. It was July 20th, and this was a very deliberate pick on the date because of its historic significance. This was the 52nd anniversary of the Apollo 11 moon landing. And the name nodded to that in many ways. They had the booster named New Shepard, after Alan Shepard, the first American to go to space. And this is a little different because this was the first time a crew had ever been on a flight. They did an uncrewed test just a couple months ago, but this is not just fully crewed. This was the first time a crew had ever been on board for a launch. And this is also a long time in the making. Blue Origin has been around since 2000, although they didn't really start making the news until 2015, when they actually were the first to land a suborbital rocket and a reusable rocket. So they've been making the news for a while, although I would say a bit more quiet than Virgin Galactic and SpaceX, their private sector competitors. Now, one really different thing about this capsule is it is designed to maximize the view. This is the most windows we've ever seen on a space capsule. 30% of the surface are all windows. The chairs are positioned specifically for that view, so you can really see that difference in the shift of an eye towards commercial versus an eye towards research. And you have temperature control, acoustic control, display panels, push-to-talk communication, which if you heard in the early contests, they were telling Wally Funk, one of the crew members, to push to talk. So you got to see that in action. And this is also different because it's a fully autonomous system. There is no pilot on board of this. This is all controls, which led to many memes online of Alexa, open the pod bay doors. But no such thing happened. The computer worked just as planned. No 2001: A Space Odyssey. So let's look at this crew. So this was a 4-person crew, of course, Jeff Bezos and his brother on board, which is really what made the news. They also boasted their first paying customer. This was Oliver Damon, who is an 18-year-old physics student from the Netherlands. Now, this is not the anonymous winner of the auction who paid $28 million to be on the first flight. They had a scheduling conflict, which was not elaborated upon. So this Oliver's father had already bid in that auction, had secured his spot on a later flight, but was moved up because of the scheduling conflict. So he's a pilot. He's very interested in physics and space flight. So he now is the officially youngest person to travel to space. And then the crew member I really want to talk about is Wally Funk. And this is endeared this flight to me a little more than I expected. So Wally is 82 years old, so she's now officially the oldest person to go to space, having beat John Glenn's record. And she is a record setter. She is a pioneer aviator. She was the first female flight instructor at a US military base, the first woman to complete the FAA's General Aviation Operation Inspector Academy, and so many more firsts. But She was also a member of this team of women in the 1960s, 70s called the Mercury 13. So you may have heard of the Mercury 7. These were the 7 men that were trained and went onto the Mercury missions. Well, this was a not officially sponsored program called the Women in Space program. And these were amazing female aviators that volunteered to go through the same rigorous training that all of the Mercury, Gemini, and Apollo astronauts went through to ultimately try and fly into space. And they had 13 crew members, which is why you get that Mercury 13, or excuse me, graduates, I should say. They were put through the same types of tests, oftentimes doing better. There's some good rumors out there that Wally outbeat John Glenn on several of those tests. But unfortunately, the times were what they were, and the program was canceled before any of these women got to fly. So Wally is one of 2 women left from this program. They're still alive today, and she finally was able to go to space. So something kind of sweet and poetic about that. So the flight itself was a much shorter experience than the Virgin Galactic flight. So you're launching aboard this 6-story tall New Shepard rocket, and that lifted off at about 7:12 a.m. Mountain Time, so our time, from Van Horn, Texas, which is their launch point. And the capsule was named RSS First Steps, again, in that nod to the Apollo missions. And the flight was about 11 minutes total from launch to when the rocket landed, and then later the capsule landed. And it flew a little higher than Virgin Galactic, up to 62 miles. This is what we call the Kármán line. So this is the internationally agreed upon boundary into space. They experienced about 3 minutes of weightlessness, and then the rocket landed about 5 miles away from the launch pad, and then the capsule safely touched down a bit later. So we'll take a quick look. We won't watch the whole clip of their experience of weightlessness. I love, again, this look of pure delight on their faces. So we'll watch just part of this, looking at the time. Oops, excuse me.
Go, guys.
Okay.
Oh, wow. Oh, wow.
Oh, wow. That's incredible.
To space. Unbelievable. Unbelievable.
Is it everything you thought it would be? Here, look. Oliver. Move your head just a little.
Oh, that's great!
Can you move your head a little, Wally Funk?
Oh, yeah. Hi, Mom! I love it.
Oh, wow, wow, wow.
Look at the blackness of space.
Unbelievable. Unbelievable.
So you can see they were flying around. They were having a lot of fun with this. They threw Skittles at each other. But with all of those windows, you really could see that view that they had. They got that great contrast of the blackness of space and planet Earth. Now, they didn't go orbital. They didn't fly for very long. So you may have heard some quotes that Wally was a bit disappointed in the view because they didn't get quite the view you do from, say, the International Space Station, which is at a much higher altitude, but still an amazing view of Earth. So the question is, are these folks astronauts? And up till the day of the Blue Origin launch, the answer was yes. But the FAA on the day of the Blue Origin launch actually updated their regulations and their definition of what it means to be an astronaut. So not only do you need to pass that 55-mile mark, which is the US official definition of space, but you need to be part of a crew that contributes to public safety or human space flight safety. So you need to be doing some sort of experiment. So Bezos and Branson failed to reach that mark during their recent flight and are not officially considered astronauts, despite having crossed that boundary. So this is the first time the official rules have been updated in 17 years. And I think they really are looking at the future of what spaceflight might bring in and what does it truly mean to be an astronaut. So what's next for private spaceflight? Bezos and Branson are continuing forward with their respective companies and their vision for space tourism. Bezos has said that Blue Origin has already sold $100 million worth of tickets for future space tourists. They did not disclose the number of tickets that is. And they already have 2 flights scheduled, Blue Origin. Now, Branson has indicated that there's over 600 people that have purchased tickets at $250,000 a pop. So the price of a condo here in Denver. And so they will continue with that vision. SpaceX is also in the game. Chun talked about their Starling Satellites, but of course they are the Crew Dragon capsule manufacturers as well, which is the way US astronauts are getting to the International Space Station and back. So Crew 3 will launch in October and Crew 4 will launch in spring of next year. That one's a little special, stay tuned. That is a friend of DMNS astronaut Dr. Kjell Lindgren is the spacecraft commander. This is his second space flight after flying to the International Space Station in 2015. So that work will continue on. Boeing is also in the game, contracting with NASA to take astronauts to and from the International Space Station. They faced some setbacks early on. NASA's put some really strict safety requirements, so they are looking at their first uncrewed test mission here coming up this month. And then, of course, we can look even further forward to the Artemis program, which is scheduled to take place in the mid-2020s. SpaceX has been given that $2.89 billion contract for the lunar lander, which will take astronauts down to the surface of the moon, which, if we look back to the Apollo missions, was also a private contractor. Grumman, which is now Northrop Grumman at the time, was awarded that contract. But Bezos isn't giving up yet. He was a contender with Blue Origin. SpaceX won the contract, but he just threw out there, he'll cover the first $2 billion of expenses if NASA will reconsider. So we will see what happens next with all of these exciting flights coming up. We also are hearing we might see SpaceX go out a little further from their comfort zone and get a contract for the Europa Clipper mission. So we will see what happens next. And I apologize, Jose, there we go. My computer was failing me to end that share. So with that, I think we can transition to Q&A. I'm sorry, we ran a little long. We didn't leave quite as much time as we normally do for that Q&A.
That is all right. We already have some excellent questions in the chat, which I will go ahead and throw your way. I have to say though, just, offering to cover $2 billion of expenses, what a life it must be. When I'm going to reach back, we've been getting some excellent questions so far. And since we have some questions that are similar to each other, folks out there, I might compress a few of them. But Chun, this is a question for you specifically around like the Starling satellites and that concept of space debris. Do we know what the expected lifespan of Starling satellites is? And then once they stop functioning, is there a process for them to come back down to the Earth? Will that debris ever make its way back down?
Yeah, that's definitely a concern. And right now, nobody really knows. SpaceX might have an idea of what the lifetimes are, but I'm not aware if they've made an announcement. But even for the the 1,700 that have been launched, not all of them were deployed. Some small fraction were non-operational for whatever reason, and and you can always expect some small fraction of anything that you make not to fully be functional. And so given the fact that we've launched I can't remember what the numbers are, on the order of maybe 7,500 satellites in space, into space over the last 60 years, and on the order of maybe 1,700 of them are still in operation. They'll be around, but they probably won't last more than a few decades, I'm guessing. And so when you're that high up, it does take longer for atmospheric drag to bring them down. So unless you have an active system for bringing them down, they will remain in orbit and will be at hazard. And as we've seen with these close calls, there have already been, I think this year, where a European Space Agency satellite, they actually had to maneuver to get out of a way of a Starlink. There was still only a 1 in 1,000 chance of a collision, but that was about 10 times larger than than their threshold of safety. And so the question really isn't whether there will be a problem today with 2,000 extra satellites, but what will happen in the future as more companies get into the game. And even Starlink, they have approvals from the government, from the FCC, I think, to have several tens of thousands of satellites. And so, the number of 100,000 new satellites in low Earth orbit is definitely well within the realm of possibility.
It seems like such a staggering number. I know I love to escape the city and see those dark skies, and I still feel like I see so many satellites up there. It's a little staggering to think that that number could go up so quickly by so much here. So I guess that's the cost of living in the future. Um, and speaking of how space might impact our everyday lives, Naomi, this is a question for you. These private companies are getting into the space race, and a lot of them have indicated that they want to use private companies for space travel. I know that Virgin Galactic is talking about having people travel around the world through space. So presumably would have significantly more rocket launches if these companies keep going the way that they're going and this becomes a successful commercial model. What would that potentially mean for our combating the climate crisis? How much of a contribution to the climate crisis is rocket launches currently? And if that number increases, what could we expect?
So yeah, that's been a big question. And really the question has been looked at with Blue Origin because one of the original stated goals of Blue Origin was to be a more green option for spaceflight. Part of this was the reusable rocket, right? We're not sending rocket debris landing in oceans to just deteriorate or crashing in the middle of Africa, things that have happened there. But part of it is also the fuel that they're using. And there are some carbon emissions associated with it, but they are using a green hydrogen fuel, if you will. So this is hydrogen and oxygen reacting and combining, which releases a lot of heat, a lot of pressure. And so you're releasing mostly water vapor with some carbon emissions. That's not to say water vapor doesn't have an impact on climate change too, right? With creating clouds and all of that. But they did try and avoid carbon as much as they could, looking towards less traditional rocket fuels. Virgin Galactic, they have argued the carbon emission is also less than a traditional rocket launch because you are using that space plane to get up to the 50,000 feet. So you're not having to have that incredible level of thrust straight up. To be determined, we'll see what the numbers are and what the change in technology might bring, as we certainly are looking critically at that climate crisis and what is the tipping point and how are we contributing to it. I would hope they would ask what is the vision for flying through space to get around the world versus an airplane and analyzing that carbon impact. I don't really know the answer specifically for that, but I know that's a topic that's coming up and that we are looking at more critically than we have ever in the past.
Actually, I have a little bit more to say about that. Part of the problem is that there really haven't been enough studies that have been done. So for people, the number of papers or researchers who have looked at this is very small. But in 2010, there was a paper that came out looking at black carbon from certain fuels from rocket launches, and it did show that it could have an impact. And what this means is that black carbon are basically just very small flecks of carbon that might be cigarette smoke size, or maybe slightly smaller. But what happens is they get injected into the upper atmosphere or into the stratosphere, and they can actually contribute to heating of the atmosphere because they absorb sunlight. But that's for one particular fuel type, and unfortunately, people haven't really done enough studies with the variety of different other fuels out there. I mean, it requires probably some cooperation from the different spaceflight companies, for them to release some of their test data about how well the combustion process is going when they for their rocket engines. But another impact by having lots of these swarms of satellites in low Earth orbit is the impact on Earth observing satellites. So not only do we have satellites like the Hubble Space Telescope, but there are satellites whose whole point is to look down on the Earth and to monitor pollution, to monitor carbon dioxide, to look at weather. So that's something that is actually also very concerning, and that came up in the conference from 2 weeks ago. And that's something that, I mean, unfortunately, the Earth observing people, I mean, who are not astronomers, but who are geologists, biologists, a lot of them haven't, or probably not even aware perhaps that this is going to be this big problem that they will be facing. And also, in another community that hasn't been reached out to, or the biologists, because there are a lot of migrating animals that rely on, we think, on the sky at night for their migration. And unfortunately, as far as I could tell, no biologists were invited, no ornithologists to the meeting from a couple of weeks ago. But I think they have to be in on the conversation as well.
That is such an excellent point. I think it's really we're pretty much out of time. We have other questions, but I don't want to keep everybody here all night. I will say though, one of the big takeaways I've had from enjoying this 60 minutes in space with both of you is that we really seem to be on the cusp of a new era of exploration in space. But it also seems to be presenting us with significant challenges that maybe we hadn't anticipated, and we'll have to navigate our way through as technology and our access to technology in space change. So I just wanted to say thank you so much for sharing your expertise with us this evening. I also want to give a special shout out to Naomi. Naomi is moving on from our museum family and going to be an adjunct professor at the University of Denver. So congratulations, Naomi. We're all very excited for you. I know we've worked very closely together over the years. I will miss you dearly, but I am glad that your enthusiasm, knowledge, and expertise will be able to inflame young minds and create more passion for the cosmos. I really do appreciate that. And we appreciate all of you for joining us this evening for 60 Minutes in Space. If you weren't able to catch the entire program, don't fret. We will be posting this to our YouTube channel, and you can find other 60 Minute in Space episodes on that same YouTube channel. Thank you, Dr. Chun, you, our curator of space sciences here at the museum. Thank you so much for that information. Thank you, Naomi. Thank you all. Have a good evening. Bye, everyone.
Bye, everyone.